Good evening, Tandrika.
Good morning, sir.
Good morning. Yeah, next, there are some few more topics which are not discussed. Especially, it is about probability.
Yes.
Probability is based on permutations and combinations. Have you gone through that book?
I didn't go completely, sir, but I went through the table of contents of the book.
Okay, right, very good.
I was planning to read tonight after the class.
Yeah. Any idea about it?
There are 3 doors to a lecture room. Anyways, can a lecture room enter and leave the room? Enter and leave the room. So is it?
This question is used to introduce permutations and combinations.
So there are like 6 ways to.
It is a general question.
So, yes, so by 1 is that?
How many ways are there?
There are 3 doors to.
Yes, 3 doors.
Oh, sorry. There are 3 doors.
There are 3 doors, right?
Isn't it 3 times 2, sir?
There are 3 in the classroom. There are 3 doors. The classroom, right? Door 1, D1, D2, D3.
Yes.
Okay. Now, the question is, how many ways can a lecturer enter and leave the room? First,
Oh, is it 3 times 3, sir?
yes, that's right.
Yeah, I did wrong.
Because see, he enters and leaves. He can enter D1 and leaves through D1.
Yeah.
He can enter D1.
Enter by D. Sorry, exit by D.
D1, D3.
D3.
So there are 3 ways entering D1. Now D2, D2, D1.
1. D2, D2. D2, D3.
D3, right? Sorry, D2.
D2, D3.
Next,
D3,
D1.
D1. D2, sorry, D3, D2.
Yes.
And then D3, D3.
So there are totally how many ways are there?
9,
3,
2, 3,
5, 6,
6, 7, 8, 9.
8, 9. Yes, your answer is right. But in the chapter, we can do like this. Enter and leave. How many number of ways of performing this task? This task can be done in 3 ways.
Yes, sir.
This task can be done in 3 ways.
Yes.
Times 3 is equal to 9.
Yes, I did that way.
Yes. Why we use multiplication here? Because we are using counting principle. In permutations and combinations, the base of all calculations is counting principle.
Yes, sir.
Principle is the main. Yeah. What is counting principle? It is counting principle. CP, counting principle. C. Tell 3 cities in Texas, nearby Texas. One is
Cities?
3 cities.
Oh, I don't know exactly. Houston, Texas, Houston, Austin.
Houston. Okay. Okay. Suppose there are 2 ways to travel from Houston to Texas.
Yes, sir.
There are 3 ways to travel from Texas to Austin. Okay. This is first road, and it is second road, third road, fourth road, fifth road. Totally, how many ways are there for a person to travel from Houston to Austin? See, he can travel in road 1 from Houston to Texas. It is 1 and it is 3. Houston to Texas from road 1, and from Texas to Austin, road 3. Next, 1, 4.
1, 5. 2, 3, 2,
Yes.
4, 2, 5.
2, 3, 2, 4,
2, 5.
2, 5. Right. How many ways are there? Total?
9, sir. 1, 2, sorry, 6, sir.
3, 4, 5.
5, 6.
So a task can be done in 2 ways. This task can be done in 2 ways. This task can be done 3 ways. So the 2 tasks consequently can be done in 2 times 3 ways.
That equals 6. Yes.
This is called counting principle. Counting principle says if a task can be done in m ways, if a task can be done in m ways and another task can be done in n ways, 2 tasks can be done consequently in m by n ways. This is called counting principle. It is based for permutations and combinations. Permutations and combinations is based for probability. Right. Yes. That's why answer is entering. Yeah, there are 2 tasks, entering a room and leaving a room.
Yes.
Entering a room can be done in 3 ways and leaving a room can be done in 3 ways. By counting, the total number of ways are 3 times 3 is equal to 9.
Yes, sir.
If you calculate it manually, we get same answer. Okay, orders are not 1. After 1, there must be 2. Where is 2?
The question repeated.
No. Then what about this? This also question number, same question, but number 1.
Yeah.
But there must be a small difference. There are 3 doors to a lecture room. In how many ways can a lecturer enter the room? from one door and leave from another door. See, there is a difference between these two questions.
Oh, isn't it the same, sir?
See, check these two questions. This question seems to be same.
And oh, yes, sir. The last part. Yeah.
This question seems to be same, but see, there are 3 doors to a lecture room. In how many ways can a lecturer enter the room and from one door and leave from another door? So in the previous problem, these are ruled out. That means
the repetition. Yes, sir. So the answer will be 6, no, sir.
only. Yes, 6 only. Because it is clearly mentioned, enter the room from one door and leave from another door. It's the main point.
Yes.
The main point is from another room, another door. So if we take, it's like this. Enter and leave. If he enters through D1, he must leave from D2.
D1 and D3.
Yes, D1, D3.
D2,
Yes.
D1,
D2,
D1,
D2,
D2, D3,
yes,
D3,
D1.
D1, D3, D2.
That's it.
Yes.
How the counting principle uses here? Entering, leaving. Okay. This can be done in 3 ways. But this can be done in 2 ways only.
Yes, sir.
Only 2 ways. Because these are 3. These are the 3 ways. But he can leave from 2 doors only. Because one door is used here. The same door cannot be used to leave. That's why by using counting principle, 3 2s are 6 only. So
Yes.
answer is option C. Now, 2, this is 3. Where is 1? It is 1. It is 2. It is 3, right? Yeah. I will introduce the symbols also. How many possible combinations can a 3-digit safe code have? There is a safe code for a suitcase, briefcase.
Yes, sir.
Mostly 3-digit numbers are there. Yeah, tell one example.
999, sir.
Yeah, 999. Sorry, 999.
Yes.
Another example, 1 2 3. Okay. How many numbers are there? How many 3-digit numbers are there?
2, sir.
Only 2, not 2, no, totally.
No. Oh, 6.
Sure?
1 2 3 4 5 6.
0 0 0. See, in numbers, this is not allowed in first place. That means hundreds place. If there is 0 in hundreds place, it is not a 3-digit number. It would be a 2-digit number.
Yes.
But in telephone numbers and codes, any number can be used in any place. Telephone numbers have 040, something like that. It is allowed there, but it is not a number. It is a code. It is a code that just like a code. Yeah, don't think mathematically that, for example, if some number is some 040, if you dial 40, it goes it doesn't go.
If we dial 40,
Yeah, so some actually number is Hyderabad code 040, some
Yes.
862439 something. Okay,
Yes.
it is a number. But if you think mathematically, 0 in this place is not valid.
Yes, sir.
So if you dial for this number, it goes, it works.
No, sir.
No,
No.
because it is a number. It is a code, just like a code.
Yeah.
So 0 is accepted and allowed in the very beginning, extreme left place in numbers and codes. Okay, but in
Yes.
numerals, in numbers in mathematics, that means in number system, if there is, of course, there can be 0, but it is there is no value for it. That means 045. It is a 2-digit number in mathematics.
Yes.
A 2-digit number in mathematics, but it is a 3-digit code in codes. Codes means secret codes, of course, or telephone numbers or something like that.
Yes.
So 0 is accepted in this place because it is a code.
Yes.
Now, see, it is first digit, it is second digit, it is third digit. You know, almost all briefcases secret code is
000.
999 or 555.
Oh.
There is no secrecy in it, and there is no option to change it. I observed many suitcases. They told 999 is its code, and in rare cases it is 555. So only mostly few codes are there, but that's why there is no secrecy. Of
Yes.
course. Now see how many codes can form now. First can be, how many ways are there for the first digit? First digit can be 0.
First digit can be 0.
1, 2, 3, 4, 5, 6, 7,
Oh.
8.
9.
That's it. How many?
1 is it 10.
10. First place can be filled in 10 ways. Filled in. Second place can be filled in 10 ways. Third place can be filled in 10 ways. Because repetitions are allowed. See, repetitions are allowed in codes. If repetitions are not allowed, it must be mentioned in the question clearly, because repetitions are not allowed, something like that. Since repetitions are allowed, it is 10, 10, 10. If it is mentioned that repetitions are not allowed, then the first case is 10 ways, the first digit is in 10 ways, the second digit is 9 ways only, because
Yes.
the number which is used in the first place cannot be used in second place, and it is 8 if repetitions are not allowed, right?
Yes.
Here it is not mentioned, it is not mentioned that repetitions are not allowed. So we can
use this.
yeah tell answer, what is the option?
720. The option, sir, is it?
I will introduce C and P symbols, of course, but those symbols are not used here.
Oh, 1, 2, 3.
So which option is correct?
The answer is 720, right?
No, you need not calculate. Just see the options.
So is it 9Q? Is it option D?
Is it 9 cube? See, 10, first digit can be in 10 ways. Second digit 10 ways. Third digit 10 ways.
So it's continuing till 9th place, right?
10 into 10 means?
1000.
Yeah, 1000, right. Which is 1000 in these 5 options?
Option E, sir.
There may be some cases.
Oh, you took 10 for the first place. Yes, got it. I thought it was for the first number.
If it is 9, we should not write 10 here. It should be 9. If it is a number, it is a it's not a number, it is a code. Clear?
Yes.
1, 2. Where is 4? Yes, it is 4. Goodwin has 3 different colored pants and 2 different colored shirts. In how many ways can he choose a pair of pants and shirt? Yeah,
6,
is
sir.
it mentioned? Yeah. There is no question of repetitions are allowed or repetitions are not allowed because these are 2 different kind of clothes.
Yes.
Yeah. Pants, how many?
Hands are 3, sir.
Shirts, 2, right?
2. Yeah. 1.
He can
1.
use 3 pants. There is no restriction or no condition. This colored pant is not chosen. This colored pant is not chosen. Like that, conditions are not there. Next, how many shirts? 2 shirts.
2.
That means, in more clearly, those 3 pants be P1, P2, P3, and S1 shirt S2. Tell one combination.
Combination 1 and 2, sir.
P1 S1
Yes, sir.
and P1 shirt S1. P1 S2. Next, P2 S1. P2 S2. Here P2 S2 is not repeated. Repetition. It is not a repetition. There is no chance for repetition.
Yes.
Now we cannot write P1 P1 or S1 S1. Yeah. Next, tell the next option.
P3,
S1.
S1, P3, S2,
Yes. Total number of ways are
2, 3, 4, 5, 6.
yes. If we use counting principle, the first task can be performed in 3 ways. The second task can be performed in 2 ways. The total
Yes.
number of ways are 3 to the 6 ways. So the option is D.
Option D.
6, option D. Got it?
Yes.
In how many ways can 2 doors be selected from 3 doors? That means you are offered 3 chocolates. Selected means selection and arrangement. 2 different tasks here. Tell 3 famous chocolates there. 5 star is there. I think
Sir,
5
the
star.
chocolate.
Yeah.
Yes, in Indian stores, 5 stars.
Yeah. Tell 3 famous chocolates there.
Here, Kisses, Hershey's,
Okay.
and
K and
Kisses, Hershey's, H.
H. Okay.
And Milky Way, M.
Milky Way, right? Dairy Milk.
Yes.
Oh, no.
No, Milky Way.
Yeah, first and last, first and third are also here in the shops in India also. That means it's the international brand.
Oh, yes, sir. Milky Way.
I think it's international brand. See, you are offered to choose 2 chocolates from these 3 chocolates. What is our first choice? Maybe KH.
Yes, sir.
If you choose HK, it is not a different choice. It is same choice. Yeah, first one and second one, no difference. There is no difference for KH and HK.
Yes, sir.
You are asked to take 2 chocolates. Okay, your first choice is KH and maybe KH and KM.
Okay.
Next, we should not write HK because KH it is a choice, it is selection. Okay, it is selection. Suppose Virat Kohli and Ravindra Jadeja is selected.
Yes.
So for a game, Virat Kohli and Ravindra Jadeja are selected by one selector. Okay,
Yes.
if one selector choice is Ravindra Jadeja and Virat Kohli, there is no difference between those 2 choices, those 2 selections. Selections,
Yes.
no first, no second. Okay. Arrangement. Suppose there are 2 chairs for those 2 cricketers. In one chair, Virat Kohli, and another chair. Yeah, there are 2 chairs. Here it is Virat Kohli and it is Jadeja. It is one arrangement. Another arrangement. These two are two different arrangements. Have you noticed the difference between selection and arranging?
Yes.
If you offer two chairs for those two persons, first chair we may be occupied. We may occupy first place, J may occupy second place, and J first chair, V second chair. These are two different arrangements.
Yes, sir.
But VJ and selecting VJ and JV are not different. Both are same. That's the difference between arranging and selecting. Selecting means KH selection and HK selection. Both are same. Yeah. Let's count the number of selections out of 3 chocolates.
Yes.
KH, KM. Next.
Then HM.
H. Yeah.
M.
See one here. In the previous case, we can use D1, D1. It was possible there.
Yes.
But only 3 chocolates are there on the tray. You are asked to take 2 chocolates. Yeah, in that case, in the task, you cannot take KK. It is not possible.
Yes.
For example, if there are some number of K chocolates, some number of H chocolates, some number of M chocolates, we can take KK. In that case, it is possible. A pack of K chocolates, pack of H chocolates, pack of M chocolates are there. You are asked to choose 2 chocolates. Yeah, I like this chocolate, so I choose KK. It is possible there. But in this present situation, it is not possible because 1K, 1H, 1M is there.
Yes.
So the next choice is not HK, HM only. Okay, HK is already there. Next, HH is not possible. HM. Next.
Isn't it that much, sir?
Yes, very good. You are right. That much only. There is no 4th choice. Only there are 3 choices only. Okay.
Yes.
So option?
Option B, sir. 3.
Yeah. In mathematically, previously we used counting principle, right?
Yes, sir.
But here, see, first chocolate can be chosen in 3 ways. The first chocolate can be chosen in 3 ways. But you are offered 2 chocolates. First chocolate can be chosen in 3 ways. Soon after choosing 1 chocolate, the tray left with only 2 chocolates only.
Yes.
Yeah, see. Yeah, there is a formula for it that is called three doors, 2 doors. Okay, that formula is 3C2. That is called 3C2. C means selection. I will tell the formula for it now. It is time to discuss formula.
Yes.
Yeah, you know what is factorial?
Factorial. I don't remember, but if you do it, I'll remember it.
See, say one number. Say one single digit.
Single digit 9, sir.
9. 9 factorial. Its general symbol is actually the symbol for factorial is like this.
Yes.
But for the convenience of typing, mostly this symbol is used. Of course, in some cases, this symbol is also used. What is 9? What is 9 cube?
9 is 27.
9 times 9 times 9. In 9 cube, 9 is repeated.
43.
Yes. Times. But in 9 factorial, it is 9 into 9 times, but not 9. Now it is 8. Next 7.
Oh, right, sir. Times 6.
Sir, 5.
Times 5.
4.
Times
3.
2. 1.
Stop. We should stop here. Otherwise, if you go like this, for just one step more, answer will be 0. So we have to stop at 1.
Yes, sir. I got it.
It's 9 factorial. Can you tell its name? Tell its value?
Its value, sir?
It's without using calculator.
Oh, okay. So,
Yeah, see, what is 4 factorial?
4 times 3 times 2 times 1.
Yes. Its value?
Its value 6. 6 times 4, 24.
Yes. What is 3 factorial?
3 times 2 times 1. That equals 6.
6. What is 2 factorial?
2 times 1.
It is equal?
2, sir.
Yeah. What is the meaning of 2 factorial? 2 factorial means multiplying 2
With the numbers
with its
before
precedent,
precedent.
not successor. Its previous number. Okay. 2 is multiplied with its previous number. Okay. What's the meaning of 1 factorial?
1 times 1.
If 2 factorial is 2, then what is 1 factorial?
1, sir.
1 is multiplied with its previous number. What is its previous number?
0.
But if you multiply with 0, it would be 0.
Yes, sir.
So
it's 1 times 1.
yeah, only 1. Of course, 1 factorial is equal to 1. There is a sense in saying 1 factorial is equal to 1.
How, sir?
So it is 1 factorial is equal to 1.
Yes,
Right?
sir.
Now,
Oh,
what about 0 factorial?
0 times negative 1.
Of course, 0 times negative 1. But negative numbers are not allowed. Negative numbers are not used. Surprisingly, the value of 0 factorial is equal to 1 only. We will make a clip for this discussion. Okay, till then let us use this concept. There is an interesting reason to say 0 factorial is equal to 1. There is a valid reason. There is a valid reason to say how 0 factorial is equal to 1.
Yes.
Meanwhile, let us use that fact. 0 factorial is equal to 1. Okay. Now, NCR means selecting R things out of N things. Symbolically, it is written as NCR. NCR means selecting R things out of N things. This value is N factorial by N minus R factorial times R factorial. What is formula for NCR? N factorial by
N minus R
into R factorial. Right. How to find these values? And there is a shortcut also to find its value. For example, if we want to find the value of 7C3, use this formula to find the value of 7C3.
7 times 6 times 7 factorial by 7 minus 3.
That is 4 factorial.
4 factorial times 3 factorial.
Right. 7 factorial means 7 times 6 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right?
Yes.
Denominator is 4 factorial means 4 times 3 times 2 times 1. Into 3 factorial means 3 times 2 times 1.
Yes, sir.
Any cancellation?
Yes, sir. The 4, the 3, the 2, and 1.
4, 3, 2, 1 are cancelled. Right. 4, 3, 2, 1 cancel. 4, 3, 2, 1 cancel. Now we left with.
Oh, we can have cancellations 3 and 2.
6 cancel.
Yes.
Final answer is
35. Yes.
But there is a simpler way for this calculation. Of course, it is correct. Most use this calculation. But see, 7C3 is equal 7 times 4 times, 7 times 6 times 5 times 7, 6, 5, 7 times 7 into 6 into 5 only, because it is 3. Lower index number is 3. Lower index number is 3. So we write, it is enough to write, it is sufficient to write 3 numbers in the numerator.
Yes, sir.
That is, start from 3, write till 1.
Yes, sir.
Same answer is 35. Can you use that technique to find the value of 10C2?
Oh, yes, sir. 9
10
times
times,
8.
10 times.
10 times 9.
That's it. That's enough.
By, oh, yes, sir.
Denominator is
By 2.
2 times
2, sir.
1. See 3. How is it written as 3 times 2 times 1?
Yes, sir.
So it is 2 times 1 only.
Oh, yes, sir.
The answer is 45.
Sir, but we have to do another 2 times 1, no, sir?
No. Yeah, it is a shortcut method. In this shortcut method, we write 3 times 2
Oh,
times 1 only.
right. Yeah.
But if we use the large conventional method, it would be 10 factorial by, see, 10 factorial by 10 minus, use this formula to find its value. 10 factorial by 10 minus to 8 factorial into 2 factorial, right? In this method, we get same answer, but it is a lengthy method.
Lengthy.
Yeah. Tell the value of 5C2. How to find the value of 5C2?
Oh, I see. 5 times 4 times.
5 times 4, that's it
Yeah.
only.
Times 4 over 2 times 1. So 10, sir.
Yeah, 10, correct only. If we use the lengthy method, we get, then also we get the same answer, right?
Yes.
Now there are some special cases. What's the value of 4C0? Use the same formula.
4C0.
4 factorial by
4 times 3 times 2 times 1.
Use this formula. 4 factorial by
Yes, sir.
n minus
4.
r. 4 minus 0.
That's 4 factorial.
Yeah, very good. Next, into times r factorial means
1, sir.
very good. 1. 4 factorial get cancels. The final answer is 1.
1. Yes.
That means 4C0 is equal to
1, sir.
what's the value of 5C0?
1, sir.
Yeah. What is the value of 7C0?
1, sir.
Yes. Because what is the meaning of 7C0 or 5C0 or 4C0? Because you are offered 4 chocolates. But those 4 chocolates are non-veg chocolates. There are 4. Is there non-veg chocolates are there? Donuts. There is a those are name for not cookie, not chocolates. I think that there is some special, just like snacks, donuts, some non-veg snacks are there. They named. Do you know their names?
I don't know, sir.
Tell for some. Okay, there are 4 cookies made of non-veg.
Yes, sir.
You are vegetarian. Okay.
Okay.
You ask to choose one from these 4 cookies. Then what would you say? I don't want
No.
anything.
Yeah.
I don't want anything.
Yes.
That means selecting 0 things out of 4 things. We got the answer is
1.
that's why the answer is only 1. I don't want anything. That's the only choice.
Yes.
That's why 4C0 is equal to 1, 5C0 is equal to 1, 6C0 is equal to 1, anything C0 is equal to 1. Okay. That means NC0 is equal to 1.
Yes.
Now, in another case, let us see another case. How to find the value of 3C3? Use the formula.
Sir, isn't it 1? I mean, sorry, isn't it?
Yeah, practically we can understand that 3 things are offered and asked to choose 3 things. How many ways are there to choose 3 things out of from 3 things?
1, sir.
One choice. Taking all. That's the only one choice. In practically. But in theoretically, what does mathematics say about choosing 3 things out of 3 things? Using this formula, what does this formula gives? Yeah, 3 factorial.
3 times 2 times 1 by
Of course, yeah. 3 factorial by
1 times 3 times
n minus r factorial.
1 minus 1.
That is what is n minus r? That is 3 minus 3.
So isn't it 0? So it's going to be 1.
Not 0, 0 factorial.
Yeah, 0 factorial.
That is equal to 1. Next, R factorial means
Once, wait,
R
sorry.
factorial. What is R here? 3 factorial.
Times 2 times 1.
3 times 2 times 1 by 3 times 2 times 1 is equal to 1 only.
Cancelled 1.
Yeah. So 3C3 is equal to 1.
1.
4C4 is equal to 1.
1.
10C10 is equal to 1. NCN is equal to 1.
Yes.
NCN is equal to 1. Okay. Next, another case. We saw, these are. What's the meaning of NC3? Out of 9 things. Option A, NC3. Of course, we rejected that option.
Yes.
What's the meaning of NC3? It should be
NC3.
it should be 9C3.
9C3.
Choosing 3 things out of 9 things.
9 things.
It is not choosing 3 things out of 9 things. Okay. Yeah, it is that meaning. Okay. It is question number 4. Where is question number? It is question number 2, 3, 1, 4. It's over, right? Now 5. Yeah, 5 is also completed. Now, how many ways can start? Yeah. Yes, right. Yes. In how many ways can 2 doors be selected from 3 doors for entering and leaving? Yeah, don't think about the second part of the question. Two doors are selected from 3 doors. How many ways?
6. 3C2.
Yeah, what is that formula? NCR is equal to
NCR equals n factorial by n minus r factorial r times r factorial.
means 3C2 is equal to
3.
Shortcut method?
Oh, 3 times
2.
2
That's it.
over
2
yes,
times 1.
2 times 1.
Answer is
3.
3. That means in that room there are 3 rooms, D1, D2, D3. Here we did not bother about and leaving the room. We did not think about it. See, 2 doors are selected. In those 2 doors, one door is used to enter and another door is used to leave.
Yes.
Number of ways of selecting 2 doors out of from 3 doors. From 3 doors, 2 doors can be selected in 3 ways. You know one thing, 4C10 is a meaningless symbol in mathematics. Can you say why? Senseless symbol. 4C10 is a senseless symbol. Because what is the meaning of 4C10? Selecting 10 things.
Oh, selecting 10
things.
from 4.
Is it possible to select 10 things from 4 things?
No, sir.
That's why it has no meaning. So in the symbol NCR, in some cases, some others use the symbol C of N comma R for the typing convenience. In typing, it is not easy to type NCR like this. That's why some books use this symbol. This is also NCR.
Yes.
Okay, let's see. The meaning of NCR is selecting R things from N things. So N should be greater than or equal to R.
Yes.
It should be greater than or equal to R. Of course, same can be accepted. 10C10 means one way.
One way.
And 10 things are there. We are asked to choose 10 things from those 10 things.
Yes.
Only one choice, taking all. Got it?
Yes.
So in NCR, N must be greater than or equal to R. If N is less than R, it has no meaning.
Yes.
Right. In how many ways can a room be entered and exited from 3 doors to them? Yeah, it's already done. Similar question is done. In how many ways can a room be entered and exited from 3 doors to the room? It is not mentioned. You should leave from another door. So
Yes.
that is 3 times 3.
Oh, sorry, 3 times 3. Yeah.
All the questions are related to doors and lectures.
Door and a lecture rooms.
There are 5 doors to a lecture room. 2 are red, yeah, 2 are red and other are green. On how many ways can a lecturer enter the room and leave the room from different colored doors, right? Yeah, different colored doors, right? The
Oh,
total
is it
5 doors. What are those 5 doors? Yeah, what are those 5 doors? See. How many red? 2 are red doors.
2 red, sir.
D1, D2.
3 are green.
That means D3, D4, D5.
D5.
Now tell the ways different color. Enter the room and leave the room different colors. D1, D2 not accepted. Okay, D1, D2 not accepted. D2, D3, D4 not accepted. D4, D5 not accepted.
So D1, D2 not accepted. D1, D3 is accepted.
Yeah, D1, D3. Yes.
D2, D3.
Yes, sir. Let's complete the first D1. D1, D3, D4. D1, D5. Right?
Yes, sir.
D1, D2 is not accepted. D2, D3.
D3.
This is entering.
Yes.
Leaving.
Yes.
Leaving, entering. Okay.
3, 1, 4, 1, 5. D2, D3, D2, D4, D2, D5.
Yes. Still, there are some more choices. There is no condition to enter through red doors only.
Yes, sir.
Lecture may enter through green doors and may leave from red doors. It's not.
But it will repeat, no, sir.
Yeah. How many are these?
6, sir.
That means entering and leaving. It can be D3, D1.
D1. D4.
D3, D2.
Yes, sir.
D4, D1. D4, D2. D5, D1.
D1. D5,
D2.
D2.
How many? 1, 2, 3,
4, 5, 6.
5, 6. These are 6. Total?
6 plus 12, sir.
That is the answer. Got it?
Yes, sir.
Now, 4 pool balls A, B, C, D are randomly arranged in a straight line. What's the probability the order will actually be A, B, C, D? Yeah, we will discuss after learning permutations. Let us see. Still, there are some about combinations. Can the team put on the floor? Yes, right. Tell it. You can answer this question. A basketball team has 11 players on its roster. Only 5 players can be on the court at one time. Is it true? Only 5 players are allowed to play?
I don't know, so maybe it's just 5. For the court, if it's smaller.
Different groups of 5 players. Maybe in the rest of the ground, maybe. Yeah, basketball. Yeah, later we will discuss such for that condition. See, our task is to choose 5 players out of 11 players on. That's it only. Think
Is it option B, sir?
option.
Option B.
That's it. Yeah, we don't know that rules, but it is very clear that 5 members are selected out of 11 players. 5 members are selected out of 11.
11.
The answer is 11.
Option B.
And you will be learning permutations and combinations from intermediate books.
Yes.
J main books, because it covers all the models. J main,
Yes.
which covers all the models along with them, along with students.
Yes.
Do you celebrate Diwali?
Yes, sir.
When?
November 12th, no, sir.
12th is on Sunday.
Next week, sir.
Next week, yeah. I think it comes on Sunday, but in my track sheet is mentioned as Monday. Let us see. If it is Sunday, no holiday. See, answer this question. How many different 5-letter words can be formed from the word orange using each letter only once? So we think about selecting 5 words out of how many words?
Or 6, sir.
Yeah, answer is
5C. Wait.
6 things are given. 5 things are selected from 6.
6C5, no, sir.
That's it.
But then there's like 6C6.
Yeah. 5-letter word, 65. Sorry, not selected. Here, city. Formed. Forming is different from selecting. The letter used here is forming.
Yes.
There are 65 ways to select. After selecting those 5 letters, we arrange 5 letters in 5 places. I'm telling one example. ABC are there. Number of ways of selecting 2 letters from these 3 letters. AB, you are asked to select 2 letters from these 3 letters. AB,
BC, AC,
AB,
BC.
AC, BC. Only 3 ways. AB, AC, BC.
B.
Yeah, right one. Okay. After
Yes.
selecting those 2 letters, you are asked to write a word. That means AB is a word. BA is a word. And AC is a word. CA is a word. BC is a word. CB is a word. How many are there?
6.
Okay. Now, selection. There are 3 ways to select. 3 ways to select. 6 ways to arrange them.
Yes, sir.
The formula for this is 3C2. That means 2 things out of 3 things.
Yes, sir.
We use the formula 3 factorial by, or 3 times 2 by 2 times 1. 2 to cancel 3. That's why 3 choices are there.
Yes, sir.
But it is arranging or forming. It is a special formula. That formula is NPR. P means permutation. That means arranging.
Yes.
Now we are learning a new formula. That is NPR. NPR formula is N factorial by N minus R factorial only. See, 3 things are given. We are asked to arrange 2 things. Out of 3 things, we are asked to arrange 2 things, right? It's 3P2. 3P2 is P means arranging, C means selecting. What's the value of 3P2?
3 factorial.
By
3 3 minus 2 whole factorial.
What's the value of 3 factorial?
3 times 2 times 1.
Yeah, its answer is
6, sir.
By 3 minus 2 whole factorial?
1 factorial, 1,
It is equal to,
6, sir.
that's why there are six choices. So, not choices, 6 arrangements. So arranging R things out of, arranging R things out of P things is NPR. NPR means arranging R things in a row. Arranging R things in a row from N things. Here the question is, how many different five-letter words can be formed from the word orange? That means 6 letters are given.
So 6P5?
Yes, 6P5. Which option?
Option E, sir.
Yeah, 6P5 is correct. After few days, they may join at 5:30.
Yes, sir.
I'm planning to connect their class. How many different 6-digit numbers can be formed using all of the following digits? Yeah, we have repetitions are there some. Yes. We will now let's learn a new topic that is about yeah. Now you can answer 9th question also. 4 pool balls. That means 4 letters are given. How many
Yes,
ways
sir.
are there to arrange the 4 letters?
4P4?
4P4, right? It is 4P4. Option C is correct. Out of 4P4, one chance is one out of 4P4 ways, one way is ABCD.
Yeah. Oh, yes, sir.
Now we are learning a new topic that is about tell 3 letters PQR.
PQR.
How many 2-letter words can be formed by PQR?
QR, QP,
3P2.
Oh, yes.
That means we are arranging. That is 3 factorial by
3 minus 2 whole factorial.
3 factorial value is 6.
6. 1.
6. That's why 6 2-letter words can be formed.
Yes, sir.
Tell those 6 PQ, PR,
QR.
Sorry. PQ, QP. PQ is a word, QP is another word. It is a word, right?
Yes.
OF is a word, FO is a word. Both are different words.
Yes, sir.
So PQ, QP and PR, RP.
PR, RP. QR, Q.
RQ. These are the 6 letters, okay?
Yes, sir.
But if are asked P, P, Q, how many 2-letter words are there? PP is a word.
PP.
If we write PP again, it is repeated.
Yes, sir. So it's
Here PQ and QP are accepted, but here PP and PP not accepted. Next,
so it's 5,
next PQ and QP. How many? How many words are there? 2-letter words?
3, sir.
2 only. In this case, 6 letters, 6 words are there. But here, only
3, sir.
because actual answer is 3 factorial by 3 factorial by 3 minus 2 whole factorial. Okay. After doing that, how many repeated letters are there?
2, sir.
That's why we should divide by it by 2 factorial.
Oh, yes, sir.
Now the question is, how many 3-letter words can be formed by using PQR? How many 3-letter words, not 2-letter words? How many 3-letter words can be performed? 3P3.
3.
That means 3 factorial by 0 factorial.
0 factorial.
That is 3 factorial only. The number of
Yes.
three-letter words that can be performed from 3 PQR is 3 factorial.
3 factorial.
The number of 4-letter words out of ABCD is without using that formula, you can answer directly. The number
4
of
factorial.
yes, 4 factorial. The number of 4-letter words that can be formed formed using ABCD is 4 factorial only. Yeah. Now the question is the number of 5-letter words using ABCDE.
5 factorial, sir.
Yes, very good. The number of 5-letter words that can be formed by using PQRST.
5 factorial.
5 factorial. But there are some cases. The number of 5-letter words that can be used by using PPQRST. The answer is 5 factorial. By how many letters are repeated?
2, sir.
That means the answer is 5 factorial by 2 factorial. As we did.
You did.
Okay. Now the question is how many 5-letter words can be formed by using the letters PP, QQ? Yes, PP, QQ only.
Oh, 5 factorial by 5 factorial.
2 factorial into 3 factorial separately.
Oh,
P
okay.
two times.
Yes.
How many 6-letter words can be formed using A, B, C, D?
6 factorial by 3 factorial.
Yeah. How many 6-letter words can be formed using A, B, C, D?
Oh, 6 factorial by 2 factorial times 2 factorial.
Yeah. Now answer this question.
How many different strings of letters can be made by reordering the letter?
6-letter words can be formed using the letters S, U, C, C, E, S, S. You can do it on the screen.
Oh, yes. Wait. Yes. Oh,
What letters are?
so it's 1, 2, 3, 4, 5, 6, 7. 7 factorial by 1, 2, 3, 4. Oh, 2 factorial times 2.
No.
Sir?
Number of yes.
Oh, number of S. Oh, sorry, 3 factorial.
Yes.
3 factorial.
Yeah, do it completely.
7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. That. 20, 23, 60. Wait, yeah, 23s are 60. 67s are 420. Option is.
Yeah, that's good. That's good. Yeah. By chance, from tomorrow or day of tomorrow, they may join. Yeah. After our class, you may continue for their class also. But luckily, this chapter is there for those students in second year, 12th class. That means 12th class. Okay.
Yes. Yes.
Yeah, study that book and go through the topics in it. Okay? Point out the topics which are very important for that exam. I think
Yes.
there are 3 online tests are there in that book. Few,
There are
few online tests are there. That means
Yes.
each online test covers few topics only.
Yes, sir.
I think there is no grand tests. I think we need to search in that book for grand tests. That means which covers all the chapters.
Yes, I think so, sir.
Yeah.
I'll take it in Khan Academy.
Go through it and find some points. That
Yes, sir.
prep 2024.
Yes, sir. That's
All right. Okay, Tanika.
Yes, sir.
Good night.
Have a good day, sir.